everyone. Thank you for joining us today for our webinar, Waking Up from the Cloud First Data Hangover with Cloudian and Intellyx. Joining us today are Jason Bloomberg, President of Intellyx, and John Toor, CMO of Cloudian. And with that, I will hand it over to Jason.
Well, thank you very much. So let's get started. So just a bit about me. I'm president of an industry analyst firm called Intellyx. We focus broadly on digital transformation. I also write for a number of publications, and a few years ago we published our Agile Digital Transformation Roadmap poster. Still quite popular, and I'll provide the URL for downloading it at the end of my talk. So let's start with the notion of cloud first, a term that people are bandying about. You hear it quite a bit, and it's important to understand that cloud first is essentially a purchasing strategy. It is basically says that if there's any sort of new investment to be done in IT, they will look to the cloud first and see if there is some sort of opportunity to meet the business need with some sort of cloud-based solution, and only decide to spend money on premises if no such cloud solution is available. So it doesn't mean that you're not going to spend money on on-premises solutions, but it does mean that if there is a viable cloud option, you will go for that first. So it's really a purchasing strategy more so than, say, a strategic architectural strategy, right? It's really about how you spend your money. So cloud first mean going with the cloud, right? I mean, you would think that these days there's just about everything in the cloud, so why wouldn't an organization make the decision to go with the cloud? Well, there are actually a number of reasons. One is, well, the cloud, especially the public cloud, may not be the least expensive. So if cost is the primary factor, the public clouds are inexpensive when you have low volumes of traffic, low volumes, quantities of data. But as you ramp up, so do the bills. And at some point, actually spending the money on your own data center may actually be less expensive. So when those big cloud bills start coming, you may wonder whether or not the cloud was the best choice if cost is the primary factor. So public clouds are quite secure. The public cloud providers, they've been hammered by the bad guys for many years, and they are extraordinarily secure environments. But they do have a shared responsibility model where they expect customers to do certain things in order to ensure security. This can be a bit of a challenge for organizations who may not be comfortable with sharing the responsibility for security with the public cloud provider. So it's not that they're any less secure, but that public clouds do require particular attention to security, and this can be a challenge for many organizations. Now, if you're looking to move applications from an on-premises environment to the cloud, just picking it up and doing a lift and shift, sticking it into the cloud, may not get you the benefits you're looking for. Won't necessarily be any more scalable or easy to use or elastic than before. In order to achieve those benefits, you may need to re-architect the application. That may be straightforward, it may not, depending upon the nature of the application. So some organizations look to that re-architecture challenge and say, well, there may be a better approach. There's also important to note that the cloud is not a high availability environment. The cloud is built to be resilient, not highly available. So large part, the cloud is built out of large numbers of commodity servers that may go down at any time, and the idea is that you're going to build your applications to bounce back from such issues and to do failover and other techniques in order to keep such downtime from impacting the end customer. But it is not the same sort of high availability environment, say, that mainframes are, where you may be running your core transaction processing on a mainframe, and you may be doing that for 20 years and never experience a single second of downtime. So that's a different kind of environment, and how you achieve higher availability in the cloud is different from how you would in an on-premises environment. And then, of course, there are many data-centric issues, which are more on topic for this webinar, that may basically, regardless of the technology, require an organization to have on-premises capabilities. For instance, data sovereignty, right? Regulations that require that data live in the particular countries that may no longer be practical in a public cloud. If you're a multinational in many different countries, it may make more sense to have data centers in the different countries in order to support that. And then there's the data gravity challenge. If you have a big data environment where very large data sets, perhaps as part of your AI initiative, moving those large data sets may not be the most practical approach for dealing with that kind of information. So it may be a matter of leaving the data where they are and moving the processing to the data, even if that's in an on-premises environment. So there's a number of reasons why an organization may stay on-premises or have a hybrid approach, both on-premises and in the cloud as well. So this brings us to the notion of hybrid IT. Now, hybrid IT is really becoming one of the predominant IT strategies in the enterprise today. And the way we define hybrid IT is really any combination of public clouds, private clouds, virtualized environments, which could be on-premises, could be in a cloud, or on-premises environments that may not be virtualized, which would include all of the legacy assets that you may have, as well as anything else that simply runs directly on servers. So the idea here is that we have this mix of different environments on purpose, in large part because the cloud doesn't meet every need. There are reasons to have on-premises assets, but we do want to bring this layer of abstraction to hybrid IT so that we don't have to worry about securing and managing and dealing with workload portability differently for on-premises and in the cloud. And this is a key point, right? And because this ties directly to the cloud storage challenge. How do we actually think of, as we do, cloud-based environments from the perspective, say, of storage or of how we deal with data? And we want to be able to do that with the appropriate abstractions. So all of these are part of the hybrid IT story. It's not just a mix of different environments. It's not just about heterogeneity. It's about this comprehensive abstraction that provides for increasingly seamless management and interoperability and portability across the different environments. So within the context of hybrid IT, storage is a key part of the story. So when you think about storage, in one sense, there is the physical part of the story, where we have hard drives, or we have flash arrays, or we have some other sort of physical technology, and we're going to be storing files on there, or objects on there, or we'll put a database. It has to be on some sort of physical medium, and this is obviously going to continue to be the case, right? We can't have software unless there's hardware to run it, right? But we are also thinking more increasingly abstracted level, where we want to be able to make hardware choices independently of the software choices and give us this flexibility at the software layer so that we can make the appropriate choices at each of these different layers of abstraction. So the reason why this is increasingly important is in large part because of the hybrid IT priorities, right? We have on-premises, public, private cloud environments. We don't want to have to think about storage differently. It's true that if it's on-premises, we have to buy the storage. If it's in the cloud, we're essentially renting the storage, and we don't have to think about the hardware in the same way. But from the perspective of the software that leverages such storage, we don't want to have to program the software differently so that if it's on-prem, it has to do one thing, and if it's in the cloud, it has to do something completely different, right? It limits our agility and increases our costs and increases the chances that something is going to go wrong, either a security breach or bugs of various sorts. So when we talk about public and private clouds, that's not the whole storage story anymore, because we're increasingly moving to the edge. So the edge could mean the cloud edge. Say we're going to build a CDN, and we're going to have CDN servers located around the world closer to our end customers. But it could also mean where the IoT gateway is, or some other sort of technology that is not in the cloud, but not at the end customer premises either. So it could be in a local data center, or it could be in a telco point of presence. And then we also have the we could call the far edge, where the devices actually are. So these are IoT devices, handheld, smartphones and other devices, and those are now increasingly part of the edge computing story as well. Clearly, our smartphones are very sophisticated computers in their own right. IoT devices may not be, right? They may or may not have computing capabilities. So all of these are part of this story, and in the IoT in particular, generates large quantities of data that we need to process and we often need to use that as part of our AI strategy. And that may take place on the edge as well. So we have large quantities of data. We may want to process them on the edge, which requires a new way of thinking about storage at the edge, but we want to make that part of this abstracted hybrid IT story so that, yes, even though we have to think about the physical part of the story, we have to put our actual drives or flash arrays or whatever it is somewhere, we also want to approach storage in an abstracted way so that we can deal with the differences between edge-based storage and cloud-based storage in an abstracted, coherent manner. So this is becoming the storage challenge. How do we actually implement a consistent abstraction across environments, both in the cloud, on premises, and increasingly on the edge as well? So what we really need to do is think about how do we bring these cloud best practices to hybrid IT? How do we not only create the abstraction, but bring elasticity and scalability and the resilience of the cloud to all of hybrid IT, including in the edge? So, well, part of this answer to that question is what we're increasingly calling cloud-native computing. So cloud-native is a hot buzzword. People love talking about it. Vendors love slapping cloud-native on their products. So let's sort of cut through the hype and talk about what we really mean by cloud-native computing. And essentially what we mean by cloud-native is that we're going to take the best practices of the cloud and extend them across all of IT. Well, now the cloud itself already has those, right? It's already scalable, it's already resilient, it already has pay-as-you-go pricing and SaaS-based availability. But the on-premises parts, and in large part the virtualized on-prem or cloud-based parts, may not have that. So we want to bring all of those cloud best practices to everything we're doing. And this is a key part now of how we're going to come up with an abstracted approach to storage that is consistent across all of these environments. So because obviously we want to deal with storage using open APIs. We want to deal with storage in a resilient manner. And we don't want that resilience to be different on premises as in the cloud, where we want to handle failovers and other things that we need to do with storage in a consistent way so that we can think about all of the different capabilities that storage gives us in this abstracted manner. So, so when we start talking about cloud-native architecture in this business context, well, we have large enterprises who've been implementing virtualization now for quite a number of years. That's quite mature and ubiquitous. It's fully adopted. Enterprises have also largely adopted the cloud as appropriate. Enterprises aren't 100% in the cloud, but that isn't necessarily the priority, right? The priority is to be cloud first and cloud appropriate, not necessarily 100% in the cloud. So looking at the web scale companies, so looking at Facebook and Spotify and these guys and saying, well, how do they do what they do? How does Facebook get their technology to work, right? They have billions of users, all go to facebook.com, all see their own page, and it just works. It's fast, it's asynchronous, and how do you actually get that to work? And obviously it requires enormous heavy lifting behind the scenes in terms of how you build out web scale data centers and all the rest. Well, how can enterprises take the parts of that are appropriate to them and combine them with the virtualization and cloud practices that they're now familiar with? And that's a large part of the business driver for cloud native architecture. If you look at, say Netflix and Yahoo and Google and those guys, they're in large part the companies that have driven the innovation in cloud-native architecture that is now available for enterprises to take advantage of. And that's really the overall trend here, is that we're able to leverage these web-scale best practices now as part of the cloud story. And now we next want to extend that to everything the enterprises are doing. So there's an enormous benefit to this, right? If we can get this right, then enterprises can leverage web-scale best practice as appropriate, right? And that can give them enormous benefits in terms of what they can do for customers. So the environments have also continued to evolve, and this slide hopefully will help resolve some of the terminology confusion. Because there's a lot of confusion. You'll notice the word hybrid is on this slide twice. It means different things in the different contexts. And the vendors who talk about multi-cloud and hybrid cloud and all this use the terms differently. So it can be especially confusing because you can go to one vendor and they'll say they're multi-cloud and another vendor says they're hybrid IT. It's like, well, what's the difference? And it really depends upon what the vendors mean. So So here's our perspective being vendor independent, right? We sort of listen to all of them and try to come up with a way of explaining this that is not specific to any one vendor. So we have the notion of the cloud. We're pretty clear on that. We don't really have to explain that. But then there's the notion of hybrid cloud, which is a term that dates back to the original NIST definition of cloud computing. That's the National Institute for Standards and Technology, part of the U.S. Department of Commerce, who hammered out core cloud computing terminology, I don't know, it's a good 10 years ago now or more. And hybrid cloud was part of the story. So they're the organization that first hammered out, software as a service, platform as a service, infrastructure as a service. They defined those. They also defined public, private, hybrid, and community clouds. So hybrid cloud, according to the NIST definition, was some combination of public and private cloud. End of story, right? Now that's what we've been using that phrase for all these years. Let's not monkey with that, right? We have pretty good understanding of what hybrid cloud is, but a lot of what we're doing is beyond hybrid cloud, and that gives us multi-cloud, which is some combination of public cloud environments. So public cloud A, public cloud B, we're going to use them both either for failover to avoid putting all our eggs in one basket, or because the different cloud providers have different services and some, we may want services from one and other services from another. So multi-cloud may include private cloud as well, but it's not really core to the definition. It's really multi-cloud refers to multiple public clouds, somehow combined to meet the needs of the business, may or may not be integrated together depending upon the situation. So we have hybrid cloud, which is public and private, multi-cloud, which is multiple public, but again, some variation, you could mix private into that. Hybrid IT, though, is both public cloud, private cloud, on-premises, virtualized, some or any combination of those. Not necessarily all of them, it depends upon what you need. But more importantly, it's that abstraction that gives us consistent management, security, and control across all of those. So hybrid IT now is a part of cloud native architecture. It's not the whole thing, right? There's more to cloud native than hybrid IT, but it includes hybrid IT as well as all the other parts of the story, cloud native story, the containers, microservices, and other parts of the cloud native architecture story that is complementary or overlaps hybrid IT in one way or another. Okay. So architectures, core enterprise architectural approaches have evolved over the last 20 years as well. Back in the 90s, we hammered out the specifics of N-tier architecture as ways of building highly scalable websites. So we couldn't have built a Yahoo or an eBay without N-tier architectures, and it's remarkable they worked as well as they did back in the 90s before we had the cloud or any of this other good stuff we've been talking about. So N-tier architectures met that need. They did provide that level of scalability at the sacrifice of flexibility, agility, and other things, but at least we got them to work. In the 2000s, we had service-oriented architecture. The core driver for that was a way of abstracting legacy assets as services in order to build more flexible and sophisticated integrations and supporting more flexible automated business processes. In large part, that leveraged middleware, ESBs, enterprise service buses, that provided the intelligence that drove the abstracted web services that were basically built out of XML, and that gave us this sort of common language across different execution environments that enabled services to be interoperable. But there were limitations there as well. SOA was hard to implement in practice. It was middleware-centric, which meant it was not very cloud-friendly, right? It predated the cloud. Cloud came along, and SOA sort of fell by the wayside. And what really rose in its place were microservices. So microservices, small bits of code independently, those are now part of the cloud-based approach, and that gave us a lot of flexibility and enabled us to drive intelligence into the microservices endpoints that web services didn't have from the previous generation. But microservices architecture was not the whole story either, because we started building large numbers of microservices, and now they were difficult to manage and difficult to coordinate, and we had challenges, understanding them and versioning them, and a number of issues. And this really led to this rise of cloud-native architecture centered on Kubernetes in large part, container orchestration platform that enables us essentially to wrangle our microservices in an architected way. So key point here is that microservices architecture and cloud native architecture are not the same thing. Microservices essentially was the earlier approach that matured into cloud native architecture, and now we are continuing to mature that. That's not finished either by any means, but it is the latest and greatest approach that brings the benefits of the cloud to all of enterprise IT. So if you look at cloud native infrastructure in particular, there's some key characteristics. Because a good measure of the infrastructure is based on containers and microservices, you can think of cloud native infrastructure as being inherently ephemeral. Right? Containers and microservices can come and go on the order of milliseconds, right? Depending upon the need of an application and whether there's an issue, if there's some sort of elasticity requirement. This is different from virtual machines in a traditional virtualized environment that provide a measure of elasticity, but to spawn a new or provision a new virtual machine might take minutes or 45 minutes, an hour. Microservices, it could take a millisecond. So they come and go very quickly, which gives us both the benefits of microservices, but also challenges, right? How do we keep track of microservices or the data that the microservices are dealing with if they come and go on an ongoing basis? So obviously that would suggest that cloud native infrastructure is inherently dynamic. So part of this is the infrastructure itself, right? Containers and microservices coming and going. Part of it is the way we build software. So there's the people and process side as well as the technology side. So DevOps is a core part or driver of cloud native architecture. And microservices support the DevOps approach, the continuous integration, continuous delivery principles behind DevOps that are now increasingly realistic because we are building applications out of microservices. Now, a third characteristic here is that cloud native infrastructure supports real-time interactions, real-time data. So we're thinking about streams of data, about behavior that's happening at the moment, in the present, and we're going to deal with information in the present, which means we have to deal with information in a stateless way, right? If we take the time to store something and then, process it there, then that's not real time. So we're going to process in a stateless way in real time, and we need to be able to scale that and deal with how we manage data in a stateless environment in order to achieve the benefits of real-time processing. And observability is the fourth characteristic, right, where we need to be able to build manageability into the infrastructure. So not just visibility, we don't just want dashboards, we want to be able to take the next step and empower our operations people to drill down as they need to in order to support all the cloud native benefits we've been talking about. So there's three core characteristics of cloud native infrastructure. I like calling these the three lesses because they all end in less, but also that indicates that we're emphasizing something that is missing, so we have to ask ourselves, well, what happened to the thing that is missing, right? So we talked about statelessness as ways of dealing with real-time information at scale, but we still have state information, right? So statelessness would suggest the question, well, how do we manage state? Well, we still have to keep track of application state. We still have to cache data in order to support scalable behavior of applications. And obviously, we still need persistent data that we need to store somewhere. So how do we do all that in a stateless environment? We can think of cloud native infrastructure as codeless. It's not that we don't have code, it's that we want to abstract the code out and deal with the behavior of the infrastructure in a declarative fashion, right? We want to be able to represent behavior, using abstracted methods as opposed to going in and coding the behavior. And then we also want cloud native infrastructure to be trustless. This is another way of saying zero trust, but we're going to update zero trust for the cloud native world. So cloud native zero trust basically leverages software-defined networking in the context of zero trust security. And that's a different way of thinking about security that a stateless scalable environment requires. So all of these moving parts are part of the cloud native story. Okay, but let's drill down onto storage because that's sort of the theme of today's webinar. So the challenge here is that we need to manage state in a stateless environment, right? We need it to be stateless because we want our microservices to process information without having to keep track of that information. We want the microservices to work independently of each other so that we can scale them out as needed in an unlimited fashion, right? And if they all have to keep track of what the other microservices are doing, that will limit our ability to do that. So we still have state information, right? We still have persistent data that we need in order to support the core functionality of our applications. We also need to keep track of ongoing application state as well. What's the application doing right now? Even though the microservices may not know what other microservices are doing, the overall application still has to keep track of stuff. So how do we deal with this without breaking the infrastructure, without providing limitations that prevent us from being scalable, right? That's sort of the risk, right? We can say, well, let's just deal with state in a traditional way, but now microservices need to keep track of each other and now it won't scale, right? So we don't want to do that. So instead, we need to take essentially an abstracted approach, as you might think, given the context of this talk. Largely API-driven, so we need to think about, well, how are we going to store information? Well, we call an API that represents the behavior of the storage, and that is going to deal with it for us. So any microservice can interact with persistent resources or abstracted stateful resources in an abstracted way. So this is a key part of the story. Another part of the story is service meshes. I can't really get into it, service meshes on this webinar, but that's becoming a key part of how we manage state as well. So stay tuned. I'll definitely be talking about that more in the coming months. So remember, what we're trying to accomplish, broadly speaking, is to maintain these cloud-native benefits, the scalability, elasticity, and the others, even though we need to maintain state information somewhere, right? And we want to do that without impacting those cloud benefits. And that's the challenge of state in a cloud-native world. So we need to take this cloud-native storage approach that has to be stateless. So what does that give us, right? Well, it gives us geographic independence. That is, from the software perspective, the software, the applications that we're creating don't care where the physical storage resides, right? It could be in a cloud data center, it could be in a cloud, it could be in a data center, it could be in this state and that state. So this gives us the ability of establishing, say, sovereignty policies. Certain data go into, certain locations, or certain data have certain, because they're sensitive, they're personal information, we have to treat them differently than other data. That can be done separately from the applications, right? So this is the benefit of abstractions, is it separates concerns. So statelessness obviously gives us the scalability, but we don't have to say, well, we have 12 hard drives, store everything there. We can abstract that out, right? Make that number 12, an abstracted number. So it's n drives, and then the n can go up and down depending upon our needs, right? So we want to be able to do that all independent of the underlying hardware. And then when we have to think about managing that storage, right, so the backups, the mirroring, all the stuff that the storage people have been doing all these years, we want to be able to do that independently of the applications, right? So again, the separation of concerns between the physical storage and the applications that leverage the storage. So we talked about codelessness, essentially as a word that represents taking a declarative, abstracted approach to representing software behavior. So software behavior, we have over the years traditionally represented as code. That's how we create the behavior of software. Now we're saying we're going to separate that into this declarative representation that is abstracted from the code. Well, we want to be able to do this for everything that we deal with storage. So data sovereignty, management, how we deal with storage as part of the DevOps toolchain, all should be abstracted, right? So we want to be able to represent how, say, cold, warm, and hot storage in an abstracted way. So if we're thinking about an application leveraging, say, warm storage versus hot storage, it does that without saying, oh, this hard drive at this IP address. You never want to get to the physical specifics in the software. You want those physical specifics to be handled, at that separate layer of concern. So in terms of trustlessness, this is the security part of the story. We essentially want to make cloud-native storage trustless or zero trust in that each endpoint has to look out for its own security. So encryption is turned on by default. right? We have a least permission strategy where we we assume everything is negative, assume everything is bad unless we explicitly know that it is safe. And we want to be able to do this at the storage level, abstracted storage level as well. So in fact, this is one of the reasons why we need to abstract our endpoints, is we want to be able to secure them without having to worry about, here's the security rules with this IP address, or that part of the network. We don't want to think at that level. We want to say, well, here's our security policies, here's how they apply to the information, and we want to be able to apply, say, a security policy to a customer record without having to worry about its physical location or how it's stored, and all of that should be taken care of under the covers. So this is all part of the cloud native storage story as well. So we have this notion of cloud first, right, which is that IT purchasing strategy, and cloud native first, where organizations are saying, well, we're going to be cloud native and extend cloud native across the enterprise. So remember, cloud first doesn't apply to everything you're doing. It basically says, well, sometimes we'll make a decision to use the cloud, sometimes we won't. It really depends on the situation. And it also emphasizes that the cloud is more important than on-premises. That may or may not make sense for you. In many cases, on-premises is the right choice. So cloud first may lead you astray if you take a too dogmatic approach to cloud first, right? So you have to be careful not to overdo it, essentially. Well, cloud native first is really an emphasis on architectural best practice, the best practices we've learned from the cloud. It covers all of hybrid IT, so it's not specific to the cloud, in spite of the phrase cloud native, which would suggest it's specific to the cloud. But that is, that's a terminology issue. It's, broadly speaking, it's about leveraging cloud best practice, and it's comprehensive. It covers everything you're doing. So it covers how we deal with the network, how we deal with storage, security, the runtime environments, the middleware, the applications, workloads, right? It's all part of this cloud native story. So it's hard to get your arms around because it's such a comprehensive view. But really the idea is that we don't want to think of this comprehensive view of IT as a bunch of different things that we somehow have to connect to each other, and it's always a mess, right? Which is sort of, IT has always been a mess. That's sort of the nature of the beast. Instead, we're saying, well, we have this architecture approach that helps us deal with the mess. We still have a mess, right? It's not like it's going to clean up the mess 100%, but at least we have this big picture approach for how to deal with it. And that's really what we want to accomplish with cloud native computing. So that's it for my talk. There's my email address. The eBizardWizard is my Twitter handle, and you can get the poster at agiledigitaltransformation.com. And I will now turn it over to John.
All right. Hey, thanks very much, Jason. That was terrific, and I think you really hit on so many really key points around this idea of cloud first versus cloud native first, and how do you rationalize all this? How do you make sense of it all? And that's kind of what Cloudian is all about, because we were a storage technology that has been around for some years, but really the maturity of object storage, which is our underlying storage platform, was the storage of the cloud, and it really solved a lot of the problems I think you identified in your talk. Because when you think about what the cloud requires from a storage platform, it's quite different than what a storage platform needs to do in an enterprise. I mean, an enterprise is typically talking about a single site, often down to a single silo of storage within that site. There was no cloud to interact with back when enterprise storage was first brought on the scene with SAN and NAS. There was no cloud, and really the concept of having to work across multiple sites simultaneously was a little bit more of an afterthought, and something that was introduced to introduce data protection. But if you look at what Cloudian was built on, the technology of object storage, that really solved and addressed all of those issues. The issue of scale, the issue of geographic distribution, and I think you hit on a really key point. You have to have the flexibility, because although I think you made the point really pertinent. That is, data has to be something you can locate anywhere. It needs to be something where the application can be independent of the data, absolutely. But that doesn't mean the application is indifferent to where the data is. The application may really care. And just as a simple example of that, think about data protection. If you're running some servers in your data center and you want to protect that data to the cloud as your first stop. But what you may find is, in the event of having to do a restore, you're having to now work over that link. And depending on what that link is, you may be looking at a pretty long restore time. So if you're contemplating a scenario where you need to meet an RTO, RPO objective that's fairly stringent, another option is to engage a hybrid cloud, where you have a copy of that backup data in your data center and another copy of it in the cloud. And that's the kind of thing that we make really easy to do with this cloud-enabled storage. That's really what we're all about. So the basics of Cloudian is it's fully native S3 compatible storage, S3 API, of course, being the language of Amazon, which has become kind of the default standard for object storage communication. But it really encompasses all the things that you talked about in your talk, the ability to scale across multiple locations, the ability to connect to cloud. And really that flexibility is the underlying value, is the ability to scale to an exabyte. So we use think big as our tagline, because that's really what it is, thinking big in terms of capacity, thinking big in terms of geographic reach. But in doing that, we introduce a platform which is also very, very cost effective. The ability to scale in enterprise storage often comes at a very steep price. That's kind of a dichotomy of enterprise storage. Is traditionally enterprise storage costs more per gigabyte as you grow. And it's always struck me as being a little bit opposite of the normal world around us where you get a volume discount. Well, with enterprise storage, you kind of get a volume penalty normally. That's not true of object storage. It actually becomes cheaper as you grow because you get more efficiency in the underlying platform. And the end result is you end up saving a lot of money versus traditional enterprise storage or even cloud storage. So it really encompasses all the things you were talking about in your speech, in your talk. So when you think about where this fits in the overall landscape of things, we often remind people this is a different class of storage. So when you talk about other storage makers such as Pure, they definitely innovated in block storage, but it was another type of block storage. NetApp innovated in file storage, but it was another spin on file storage. Cloudian is object storage, which is a totally different storage class from any of those things, and it's really intended to solve the capacity problem. So this gets back to what you were saying, Jason, about having different capabilities in different spaces. You talked a lot about microservices, which is something we hear our customers talking a lot about, which is the ability to launch things quickly, spin up new applications, perform some analysis on data, for example. Well, just because that service is micro doesn't mean your data is micro. The data, in fact, could be quite macro. So we hear customers talking about doing this on, bio data or on, M&E data, where they're dealing with, enormous video files, or they're doing analysis of financial records. So the data they're operating on could be quite large, but they all share a common characteristic, which is that you have to access that data very rapidly, so that you cannot have the data sitting off on tape. You cannot have it sitting in a salt mine somewhere. It's got to be immediately accessible. And that's exactly what we do, is provide rapid access to, really large pools of data. So where you'd use this, it would be as providing an archive copy for either media and entertainment or data protection. Another example would be, big data, machine data, where you're collecting log data from across a wide, infrastructure of either firewalls or other types of devices, and you need some place to store that data and then analyze it to look for threats. It'd be another perfect application for this kind of thing. Or bioinformatics, where you're storing bio data and then performing analysis on it. So that's really where Cloudian fits, is it's solving those large capacity problems, as opposed to the more speed-intensive, smaller capacity problems addressed by guys like Pure or NetApp. So what really sets the platform apart in how it addresses the needs of the cloud is really a list of things, a list of attributes that apply to this class of storage. And in many cases, these are really, this collection of stuff is really unique to this type of device. So that, this list includes things like multi-tenancy. It's an absolute essential for this storage type. It has to be shared across different environments that you do not want to have visibility across environments. You absolutely need that data to be secure, yet operating in a single storage cluster to provide management simplicity. It also has to be, a scale-out architecture, because if you have an architecture which is difficult to grow, how are you ever going to manage data expansion? Now, I think that was really the underlying thing for the cloud was traditional SAN and NAS just did not provide the ability to grow easily. The scale-out architecture of object storage did that, and then of course it has to be able to scale across regions. You can't just scale within one data center. You need to be able to scale across multiple. And this really gets to the point you were making, Jason, about keeping the data accessible to the application, wherever that may be. We can put data anywhere within a single physical cluster. So you don't have to say, well, this cluster exists only at point A. This cluster can exist in Chicago, Los Angeles, New York, and in fact, that data can physically be anywhere in that cluster and still managed under a single roof. And that's a tremendous amount of flexibility. And then, of course, the other part of this is the public cloud compatibility. I mean, none of this would really solve the problem completely if you couldn't address, the hybrid and multi-cloud environments that you were talking about. So the ability to not only move data to and from those environments, AWS, GCP, and Azure. Obviously, you need to be able to do that. But more importantly, you need to be able to manage data across those environments, view data across all those environments simultaneously from a single screen, and be able to search it as well. If you can't find it, what good does it do? So you have to be able to do all those things that involve data management, but do it in these multiple environments all at one time. This is the collection of things that really set this class of storage apart and make it so useful for addressing exactly the problems that you talked about in your speech. So I think what's really important here is that this is the infrastructure that was built for the cloud, and you can think of it in a very simple way in a private cloud where you're operating in your own data centers or colos and providing an environment that's highly scalable and flexible, but not necessarily tying in the public cloud at the same time. But you can take that exact same infrastructure with absolutely no modifications, no extra software, nothing else to add or manage. You can take that exact same infrastructure and deploy it in the hybrid cloud. And fortunately, I'm happy to say our definitions of hybrid and multi-cloud are exactly the same. So there's no confusion here. We're talking hybrid cloud and usually one of the cloud providers, pick your favorite. But then also multi-cloud. And here we're talking about managing data across multiple public clouds and even multiple private clouds. And in all three of these environments, whether you're talking private, hybrid, or multi, in all three of these environments, you have the ability to see and manage data on a single screen. So a single view, single search capabilities. You can go in with Elasticsearch, visualize data with Kibana, and you can do it across all these environments. And that's just so powerful for managing exactly the kind of problems that you were describing in your talk. So this is kind of the underpinning of what we do. That's why I was so thrilled to have you here to chat with us today. Is just that what you're describing so perfectly describes what we're here to do. None of that would make any difference if it was unaffordable. The best solution in the world is not a solution at all if you can't afford it and you can't maintain it and you can't fit it in your data center. So I'm happy to say that we win on the economy one too, because compared to conventional storage, it is far more cost effective, takes up far less space. We just introduced our product. Our new product was co-announced with Seagate in June, called the Cloudian HyperStore Extreme. That's 3 petabytes of usable capacity into just 8 U of rack space. Tremendous economy. If you take that same amount of capacity and you put it in a traditional storage environment, you're talking about a lot more space and obviously a lot more CapEx as well. So yeah, it does solve all the problems that we were talking about in terms of cloud, but it also solves the economy problem, which is to everyone an equally compelling part of the overall equation. So, with that, I would just say this is the storage of the private cloud. It's well recognized in the enterprise community right now. We've got hundreds and hundreds of customers using this today. If you go to Gartner Peer Insights, Cloudian has a 94% recommended rating. It's the highest recommended rating of any object storage provider. We also have the most reviews of any object storage provider. And it's used at, some of the largest corporations in America, many of which you interact with every day. If you are, interacting with media, if you're interacting with financial data, if you're interacting with, your bank, you're probably at some point during the day, you're talking to a Cloudian storage device. But encourage anyone.com. We have a free trial. This is offered both as a software solution and as an appliance solution, so you can actually download the software. I have it running on my own laptop. You can just run it inside a VM. It's very easy to install. You can try it out for yourself and see how easy it is to use. So with that, I think we're just about at the time to get into the Q&A. So I am going to turn it back to Laura to see where we are on questions.
Thank you, John. I would like to just take this time to thank Jason and John for this really great, informative presentation on the differences between cloud versus on-prem, the rise of the cloud-native architecture, and the value of S3 native on-prem object storage environment for private, hybrid, and multi-cloud. Hopefully, you guys all got a lot out of this webinar. We do have some time for questions today. So just a reminder, please go ahead and enter them in the tab at the bottom if you haven't already done so. We do have some questions so far, so let's get started. First question is, what does the S3 API offer versus other communication protocols?
Yeah, thanks, Laura. That's actually a really good one. I kind of skipped over the S3. S3 API is, of course, the language that we use to talk to the storage type. It's the same language that you use to talk to the Amazon Simple Storage Service, which is also called S3. So that's a first point to clear up. Is when we say S3, we mean the language. When you're thinking about the Amazon Storage Service, that's also called S3, which is very confusing. But that is a service. We're not part of that service. We use the language. And really, what's exciting about this API or this language was that it was the only storage language that was invented in the age of the internet. If you go back to when blocks came along, when file storage came along, those were both predating the internet. So S3 really is the storage language that was built for the internet. And what this does is it really allows the management of data large amounts of data at a distance. So you're interacting with storage devices which are remotely located. As an example, one thing the S3 API lets you do is when you're doing a large data transfer, say you're transferring a gigabyte of data, it will break that transfer up into small chunks and send those individually. So if any one of them gets lost along the way or you have a drop packet, all you do is retry on that one part of it. And you don't have to retry the whole thing. This is the technology, by the way, that made Netflix possible. If you had to stream your whole file to your iPad before you watched the movie, it'd be a whole different experience. So S3 API solves the problem of cloud storage and managing data at a distance.
Okay, great. This next one, it looks like maybe it's for Jason, although John, please feel free. It says, how can cloud natives be stateless if we have data we want to persist?
Well, yeah, that is an important question, and it remains a point of confusion. But this is great that this question came up after the one about the S3 API, because that is a perfect illustration of how this is supposed to work, right? We have this API that abstracts some of the specific storage interactions, just like the one John was talking about, the retries of different parts of the message. That's the sort of thing that you don't want to have to worry about at the application level, right? The application simply says, well, I'm going to call this API and send the data I want to store, as per the specifics of the API, or read or write whatever you're trying to do at the time. And that's independent now of all of the physical interactions beneath. So that's really what we're trying to accomplish when we talk about dealing with state information in a stateless environment. Because now the applications are free to, scale appropriately, right? Where you could have individual microservices calling that API independently of each other without having to worry about what the other ones are doing, right? If they're doing reads. Obviously, if you're doing writes, then you have to track how.
Great. So it's scalable. How is this solution different?
Yeah, that's unfortunately I'm in the marketing world, which is we're kind of caught up in marketing jargon sometimes. And scalable is, of course, the storage word that's been around forever. And then traditional storage infrastructures, what scalable normally meant was you just add more of the same. So you take box A, box C, box B, box C, and put them all together. But what was really happening under the hood was you had 3 totally separate storage environments. So you had to have a way of managing the data in between box A, box B, and box C. So there had to be another layer in there. And in many cases, that extra layer really got in the way of truly efficient storage management. Object storage doesn't work that way. Object storage has an underlying namespace that spans everything. And you say, well, what's different about it? Why does it do that? And the reason is it's flat. There's no tree, there's no hierarchy, there's no branching off that has limits. And in fact, the underlying address space, the practical limits on the size of that address space are essentially unlimited. It comes down to the number of fundamental particles in Earth is the fundamental limit. So it's essentially unlimited. And that is not true of any other storage type. Everything else uses some kind of a address space which has limitations built in. So again, it's the storage type that was designed with the cloud in mind. And that underlying some of the decisions that were made day one of object storage fundamentally address the problems that we have today.
Okay, great. There's another question. It's about one of your slides, John. It says, how did you arrive at your 70% cost savings figure?
Yeah, the cost savings is another thing that gets used in marketing a lot, and again is often unsubstantiated and sometimes is marketing fluff. But in this case, there's some very real reasons why the cost savings are quite tangible. And one is that the underlying infrastructure, we use all commodity hardware. I mean, this is not a platform that was built for high speed, so we don't need to use anything unique and exotic that drives performance. And that's different from most other storage types out there. Most other storage types are really built with performance in mind and have to use some exotic componentry to get there, or even custom hardware. This is built entirely on commodity servers because it's built for scale, right? So really what matters is the software and how all these commodity servers work together. The second thing is that as the system grows, it stays simple. This is a peer-to-peer clustering environment. So every peer is a complete peer of every other peer. There's no controller, there's no boss. Every guy is in charge. So what that means is you have a very uniform infrastructure that stays just as simple when you get to 100 boxes as it was when you're back at 3 boxes. That's different than traditional enterprise storage, where as you grow, you have to add layers of things that are now managing the data between all those boxes. So it starts simple as you're small because it's all built on commodity hardware, and it stays simple as you grow because that peer-to-peer architecture, other than the number of boxes, never gets any more complex. It always stays the same.
Okay, great. Jason, I think this one's for you. I think I want a little bit more clarification. The question is, what's the difference between cloud first and cloud only?
Well, it's important for people to understand that while a cloud-first strategy makes a lot of sense for most organizations, you don't want to make the assumption that simply because you're cloud-first, that means cloud is always better than an alternative, typically on-premises solution, right? Because it's going to depend upon the particular situation. Really, it means that you want to look at the cloud and make the judgment call about the cloud as a way of ensuring that you're not jumping to the conclusion that on-premises is the best approach, right? That's what we're trying to avoid. So, so it's really a matter of making the cloud appropriate, right? Making the appropriate decision based upon the situation. And we're looking at the cloud first as a way of balancing the fact that we were on-premises first before. So in terms of cloud only, that is a particular situation where there is a business reason to be entirely in the cloud. We don't find that to be very common in larger enterprises. So, obviously for small companies, that's very common. I mean, here at Intellyx, we're a small firm, and all our stuff is in the cloud. It's like, where else will we put it? We don't have a data center. So, but for larger companies, it's a different story. So the cloud only is more about the smaller companies. It's more about the pure web scale companies. But even pure web scale companies, it just means that they're building their own clouds, right? So it's in the cloud, but it's still their own data centers. So it's a bit of a gray area. For the enterprise, what's important is really to understand that you need to make the appropriate decisions based upon the needs of the business and the customers at the time. You don't want to jump to any conclusion whether or not it's cloud or not cloud.
Okay, great. I think we have time for one more. I had one that said, we've had a hard time adding capacity without disruption. How does Cloudian handle this?
So the questions are on growing without disruption, which is, that's a really key question about how does the environment scale? And the answer is, non-disruptive growth is a key requirement for making things work in the cloud. If you don't have the ability to grow without disruption, that means downtime. And of course, when you're dealing in a shared storage environment, downtime is completely impermissible. You can't schedule downtime amongst a large volume of users. So what we do is provide an environment where each storage node operates independently, and when another storage node is added to the scene, it then it folds itself into the existing storage environment. So you have the ability to rebalance. The data gets moved from the existing nodes to the new node on an as-available basis. And all of the nodes are working amongst themselves to provide that balancing capability. So this means that, that's something which is transparent to the user. It's a very cloud-like experience, and that's part of this whole thing. It's lights-out management. It's simple. It's cost-effective, and it stays simple as you grow.
Okay, great. So that's all the time we really have for today. I apologize if we didn't get to your questions. We will follow up with you to ensure that your question is answered. Thank you again, Jason and John, for your time today, and also to our audience for joining. This concludes our webinar. Thank you.